An algebraic expression could be 2x, or it could be x squared plus 2x plus 3. Those are all expressions. An equation would be if we put equals a number. Okay, so we're not looking at equations yet, just looking at expressions. And then today we are looking at evaluating, which is when you substitute a number in for variables and follow the order of operations, which we will be doing without a calculator today. So, I'll start you off on number 1, but I'm actually going to let you do these two on your own. They're the easier ones. Example 2 is the more difficult, which are the ones I want to go through. Which again, all of this is reteaching. It's not new teaching. It's something you should probably know how to do from your summer packet. But brief review. Evaluate this expression for k is 6. So we're going to plug 6 in for k. Again, without a calculator. See if you can finish that. And also do letter B. Evaluating this expression for the given values. 20. Who can tell me what they got when they evaluated this one? And I'll set up the problem for us. Again, parentheses are going to be your friends. That way you don't think it's 3 minus 2. You know it's 3 times negative 2. Just to keep yourself organized. Who can tell me what they got for this one? Courtney?
Negative 44. No.
Close. You just had one little negative mistake there that caused your final answer. Danielle?
Positive 44.
Nope. William? Or
16.
what? 16 is correct. Do you go by William or Will?
William.
William? Okay. Should be getting positive 16, so let's take a look at that one. So obviously we get negative 14 here. Now, for these three numbers, these are all being multiplied together. So really, it's negative 3 times negative 2, which is positive 6. Positive 6 times 5, which is a positive 30. Now remember, the commutative property says you can multiply in any order. So if you prefer, you could do 5 times negative 2 is negative 10. Negative 10 times negative 3 is a positive 30. Doesn't matter. You could also do negative 3 times 5, but that gets us 16. So the biggest mistake I see is with negatives. So that's why I want to make sure we go over the next example together. So we are given 3 examples with a given statement. C is negative 3 and B is 5. Make sure you use parentheses. It makes a huge difference in your answer. So a parenthesis negative 3. Let's see, the squared has to go outside the parenthesis. Make sure you don't put it inside. Minus parenthesis 5 squared. And this one's pretty simple, but the other two are the ones that can get difficult. So we'll square these, and then we'll subtract. We'll get negative 16. Some people think they're too good for parentheses. They can do it in their head. Please don't be one of those people. All right, now last year when I taught this class, I did the first 2 examples, and then I let them try these on their own. And it was like a nightmare. Like we had like 7 different answers going around, and only one of them is of course correct. So that's why I actually changed my game plan this year and decided to do these ones with you. So let's go ahead and substitute in our values. I'll wait till everyone gets there with me before we move on. Again, use parentheses when you plug in this negative 3, and make sure you put the squared outside. All right, so now we're following our order of operations, which this is the kind of stuff you're going to see on your summer quiz tomorrow, right? You have order of operations to evaluate. So this is more practice. We want to go to parentheses first. And sometimes I would do that at the same line of work, which is fine if you do that too. Now we're going to go to our exponents. Now here's where the students made the mistakes. When they wrote it down, they were like, oh, minus a negative is a positive, right? I can just change that to a plus. So if you try to start doing things in your head that you're not allowed to do. You have to do your exponents before you do your subtraction. Okay, so we'd have negative 3 times negative 2 minus 9. It's not plus 9. Now we go to multiplication. We're going to multiply those together to get a positive 6 minus 9, which is a negative 3. But that's where students will write like this. They'll write minus, and they'll start writing -3, and they'll be like, oh, that's just a plus. You cannot do that. Okay? Same thing with the next one. Let's sub in our values. Now be careful. This is minus d squared. What this actually is, and this is something I'll see a lot, it's really -1 times d squared. They just don't put the 1 and the times sign. So make sure whenever you do this that you leave the negative outside and we just put a 5 inside. You're not squaring the negative, you're only squaring d, which is 5. Minus 4 parentheses 5 minus 2 times -3. So again, we're going to start with our parentheses. And I'll admit that sometimes like I do my parentheses and exponents together if they're like on different parts of the addition subtraction sign. But I'll try to keep it nice and by the book for our board problems. Inside of here we have to do our multiplication first. -2 times a -3 is a positive 6. Add those together to get 11. And then now we're going to go to exponents. Again, this is 5 squared, which is 25, but there's a negative outside, so this is a -25. Oops, I copied down the wrong symbol. Sometimes it's a copying mistake, not even a negative mistake. This is a -4. So that's going to get me a -44. So we should get a -69. So just be careful because a lot of students will think that this is -5 squared, which gets us 25, and then they would subtract 44. All right, we are going to skip over example A, just because it's going to get you some, well, we'll skip over this one. We'll do the next one. It gets you some really big numbers that you would have to do without a calculator. But not super big, but a lot of decimals. And the next problem is kind of the same thing, but it has smaller numbers. So we'll just do this one. So these are real world problems that give you an equation or an expression to model some sort of scenario. So this expression models the percent of eligible voters who will be voting in the future years. Y represents the number of years since 1960. What percentage of eligible voters will be able to vote in 2012? So all you have to do is plug a number in for Y and then do your order of operations. But what number should we be plugging in for Y? Should we be plugging in 2012? William?
52.
52. How'd you get that?
2012 minus 1960.
Good. It says the years since 1960. So you're saying how many years since 1960 is the year 2012. So we'll subtract those to get that Y is 52. Now we evaluate plugging 52 in for Y. So we have -0.3 times 52 plus 61. Now if you're doing this without a calculator, you would want to do some side multiplication probably. You don't want to include the negative. You'll just multiply 52 times 0.3 and then just attach a negative whenever you throw it back in. So when you multiply, remember, you just ignore the decimal point, and then at the very end, we see how many times you had to move over, which was just 1, so we'll move this over just 1. Let's suppose that there was a decimal point up here too. You would move it over 1 and 2, and then you would move it over 2 spaces. Remember all of our rules. So now we'll take this, plug it back in, and again, use the negative. And what do I get whenever I add those numbers together? And if you need to, you can stack your numbers and subtract. So you could do 61.0 minus 15.6 if you need to. What do we get? John?
45.4.
You got it. And they said that that was the percent of eligible voters. So we'll tack on a percent. Anytime there's a word problem, if they tell you the unit, you should tack that on. All right, on the back, we're just reviewing combining like terms and distributing. So some vocab, we have a term, which is a number, a variable, or a product of a number and one or more variables. So you can see that these are terms. Coefficients, as we know, are the numbers that go in front of the variables. And like terms are terms that have the same variable raised to the same power. So an example of like terms would be 2x squared and 3x squared. We can add those. Now, when I add them, do I get 5x squared or do I get 5x to the fourth? Yes. When you're adding like terms, you just add the coefficients and you keep the terms like. Just like common denominator, you add the numerators, you keep the denominators. Now, for multiplication, which we're not going to be doing much of this, but you will see it throughout the year. So 3x squared. If you're multiplying, you don't need like terms to multiply. You can multiply any variables together and any numbers. So you would multiply the digits, the coefficients, and get 6, and then you would add those exponents and get x to the fourth. So just realize the difference between multiplying any terms together and then adding like terms. All right, example 3, simplify by combining like terms. What would I need to do first in example 3a to start simplifying? Autumn? Distribute. I need to distribute a positive 7 to everything inside of our set of parentheses. And then we'll just combine our like terms, anything that has the same variable raised to the same power. So we have 2h plus 14h, which will get us 16h. And then just be careful with your signs. This is a negative 3 and a minus 21, which will get me a minus 24. Okay. See if you guys can try examples B and C on your own, and then we'll go over those answers before we look at our geometry problem. More than one like term. So in this one we have 2x squared, we have a minus 4x squared, and we have a minus x squared. So 2 minus 4 is negative 2, and then minus x squared is really minus 1x squared, which would get me a negative 3. And then our x's we got correct, which was 5x plus 1x, which is 6x. All right, and then L. What did you guys get for C?
Okay. I got negative 4r.
Close. We're missing an S. Justin?
Negative 4r minus 4s.
Yes. So we have double distributing in this problem. The negative 2 needs to be distributed to each term. So negative 2r minus 2s. Now in the second set of parentheses, you need to distribute a negative sign, or a negative 1, to both terms. So this will become a minus 2r and a minus 2s. So anytime you see something outside of the parenthesis, like smack dab up against it, that's being multiplied through using your distributive property. And if there's no number, it's understood to be like an imaginary one. And then combining your like terms. That and that, we get negative 4r minus 4s. So just always be careful with your distributing. So the last problem we have then is finding the perimeter of the figure below. This is not a regular shape, it's irregular. It's like a rectangle with a square cut out of it. But they want us to find the perimeter. There's no formula for perimeter of something like this. So how can I find the perimeter of this shape? Al? That would be more useful if we were finding the area, not the perimeter. So if we were cutting these, you're thinking about breaking these into, and then that would work really well to find the area, which would be the space inside. We don't actually have to do that. Brent? Just add them all up. That's all you're going to do. Now make sure you get every side, even the ones that are like going in the shape. So we have 2c, I'll just start here, and I'm just going to go clockwise around the shape. And you could do some of this mentally, like 2c plus 3c is 5, 5 plus 2 is 7, if you want to shorthand everything you're writing. But 2c plus 3c plus 2c plus, now we have this little weird thing. Okay, I'm just going to write it down as is for right now. Now we have 1d plus 1d plus 1d. Instead of writing all that out, I'm just going to put plus 3d to save myself a little bit of writing, because there were 3 of them. And then I have to add my last little piece, which was this. Alright, so combining my like terms, we have 2 plus 3 is 5, 5 plus 2 is 7. So we have 7c, we have this 3d, and then we have this stuff. In order to add fractions, we need a common denominator, which, lucky for us, we have one. So that common denominator is going to stay common of 3. We're going to add the numerators.
Please excuse this interruption. Varsity golf is now dismissed. You will leave from the athletic entrance. Varsity golf is now dismissed. Please leave through the athletic entrance. Thank you.
So we'll add the like terms in the numerator. So we'll get 9c. Now be careful, this is a negative 1d minus 2d, which will get me a minus 3d. I gotta move this table. I bumped into it like 1,000 times. Alright, now this big fraction, this is really being like grouped, but you can split it into 2 separate fractions or just divide each number by 3. So this is really 9c divided by 3 minus 3d divided by 3. And those numbers divide in nice and evenly. So we get 3c minus 1d. Now don't forget about the other terms that we had before. Bring those down. And this was a plus sign. And then at the end, combine those like terms. So we'll have 10c. 3 minus 1 is plus 2d. And that's your answer. You're not going to get a numerical answer, you're getting an algebraic expression. Alright, complete the closure on your own and then we'll share our answers. Then you guys will have some time to work on your homework here in class, so